Welcome to D-Lab. In this video we're going to do an initial inspection on an Altec Model 353A home integrated audio amplifier. This is a tube type amplifier, considered a pretty rare piece. A local guy brought it to me for evaluation. Story is it had already been at another repair shop for them to look it over. They turned down the repair, and when the owner returned home, he looked in the back and all of the original tubes were gone. He believes that they are all the mullered type, so there was 4 6L6s and 5 12AX7s. Bummer. Alright, let's give it a look over and see what it needs. Well, let's give the Altec an inspection. First off, front panel, you can see cosmetics are great. All of the switches and controls feel good. No loss of decals on the front panel. She really looks nice. Let's take a look topside. Okay, we'll start with the rear panel. You can see all the RCA jacks look good. Speaker jacks, all the screws are there. It's a good deal. Inside, remember, all the tubes are missing, but it gives me an opportunity to look at the sockets. They all look primo. I did notice that this thing has a circuit breaker rather than a power line fuse. These are known to fail from age, and that may be what caused some damage that you're going to see underneath. All the transformers are made by Peerless. It still has the original filter caps, and this one here caught my eye. It looks like some little metal woodpecker was plucking on the top of the cap. Have no idea what it could cause that damage. All the 9-pin sockets look good. All the controls look uninterrupted. This is a really nice unit. Let's look underneath. Well, here we go, bottom side, and the first thing that caught my eye was this resistor. Do you see something wrong with that resistor? Like maybe half of it's missing? And if you look here, there's some little pieces of the nichrome wire. It's a wire wound resistor. I checked the schematic. This is a 4 ohm 5 watt resistor. It was turned down, and you can see a black scorch mark on the chassis, and in this area somebody attempted to clean it. So obviously we're going to have to investigate that. So right off the bat, obviously we're going to need 2 new filter caps here. This main guy's got to go. All these green caps, coupling caps, they all have to leave. Update those. Got some bumblebees strapped across the 6L6s. So when I see this kind of damage, I assume that that circuit breaker did not open when this amp developed a short. So what I'm concerned with is for this resistor to blow the way it did. Possibly one of the output transformers was damaged when that event happened. So we're going to buzz out the primary of these output transformers. So the power supply goes through that resistor, obviously, and there is a diode here. Okay, that diode feeds a resistor down here. They say it's like 125 ohm resistor, and there he is. So we go through that resistor, got about 105 ohms. From there, it is going to go over to pin 3 of each of the output tubes. So when I measure this, I'm hoping to see some type of low resistance, hopefully under 100 ohms, but obviously not shorted or open. Okay, so we're going to look at every one of the 6L6s. So 1, 2, 3. There's about 56 ohms. Go to this one, same thing. And there we go, 55. And about 51. So I know that the high voltage is going through the primary of the transformer, which is the center tap, and then it feeds each of the 6L6s. So both of the output transformers didn't take that hit. But there's obviously something else in this amp that is shorted, or possibly one of the original output tubes shorted and blew that circuit. Let's hope. The other thing I found is pretty interesting is pin 8 of all these 6L6s are strapped together, and they come over here to one cathode biasing resistor. Okay? So that 150 ohms feeds all 4 of the tubes. So when you set your bias, you obviously have to monitor that voltage and calculate your current through the output tubes. That's pretty unique. Okay, so we just verified that the high voltage is making its way through the center tap of the primary of the output transformers and gets to pin 3 of each of the 6L6s. But the other thing you'll want to check, obviously, is to make sure that one of those lines is not shorted to chassis. Okay, so we're still on ohms. Got my clip on the chassis, and you do the same thing. You just go to each of the pin 3s and make sure that you do not see a short to ground. So I'm sure you guys have noticed in my recent videos that I've been using a new handheld meter. This is the Hioki model DT4256. In the past I used to use B&K's, Beckman's, and occasionally a Fluke, but I found that the update rates of the digital readout lagged. So I picked up one of these Hiokis because they advertise this that it has a very fast update rate as compared to other meters. And yes, it does. I'm really impressed with this meter. I like the feel of it. It's very solid construction. I've been using it for a year now, so I thought I'd go ahead and let you guys know that this is D-Lab's first choice of handheld meters. You can pick these up for around $230, and the vendor that I found it through was TE Equipment. Okay, inspection is complete. I have contacted the owner and gave him an estimate, and he said let's go forward. So after I get my parts on hand and get some life into this amp, we will do a follow-up video. Hope you guys enjoyed it.